In this video, I'm going to show you how to find the equation of a quadratic function containing the points -1, 12, 2, -3, and 6, 5. This technique will work for any 3 points that are non-collinear as long as no 2 points of the 3 have the same x-coordinate. Anyway, to solve this problem, it's helpful to know that any quadratic function is y equals ax squared plus bx plus c, and of the 3 points given, each one is an ordered pair where the first coordinate is x and the second one is y. So using these two facts, I can turn each one of the 3 points into an equation. The first one, the y is 12, so let's just put 12 there, equals a times the x is -1 squared plus b times another -1 plus c. The blue one, -3 is equal to a times 2 squared plus b times 2 plus c. And the purple one, 5 is equal to a times 6 squared plus b times 6 plus c. And let's just go through and clean each one of these up a little bit. 12 is equal to -1 squared is 1. 1 times a is just a. B times -1 is minus b plus c. For the blue one, -3 is equal to 4a plus 2b plus c. And the purple one, finally, 5 is equal to, that'll be 36a plus 6b plus c. So what happened, even though the function we want to find is a quadratic, putting these values in for x and y in this form gives us a set of 3 linear equations, each with 3 variables a, b, and c. And if I solve this system for a, b, and c, and then put those values back into the form here, then we'll have the equation of the quadratic function. So if you're not familiar with solving a system of 3 linear equations with 3 variables, then one way I can show you to do it by hand is to choose a variable that you want to eliminate. And in any one of these problems, it's always going to be c, because it just ends up being the easiest. Anyway, to eliminate c, I'm going to choose 2 different pairs out of my 3 equations that I've constructed, and in each pair I'm going to multiply each equation by whatever constant is necessary, so that when I add the equations together, the variable that I chose, which was c, is eliminated. Basically, you want the coefficients of c in the 2 equations to be opposites. The reason c is the easiest to eliminate is because in all 3 of these equations, the coefficient of c is 1. You just have plus c plus c plus c. So all I need to do is multiply one equation out of each pair by -1. If I do that twice with 2 different pairs of equations, then I'll end up with 2 equations that each just have a and b. I can repeat that process again to eliminate one of those 2 variables, and then that's an easy equation to solve for whichever one's left. And then I can systematically go back through the equations that I have and find the second and third variable values. So let's start by taking the yellow one. Let's go the yellow one. 12 is equal to a minus b plus c. And from that, let's subtract the blue one. So multiply the blue one by -1 and then add them. So -3 times -1 will be 3 equals, and we'll have minus 4a minus 2b minus c. And you can see when we add these together, I have, let's make this in green, 15 is equal to -3a minus 3b, and c is gone. So this is one of my equations that I'm going to end up working with, and if I want to deal with this equation, I'm going to make it as easy as possible. Everything in here is a multiple of 3, so let's divide the whole thing by 3, and actually, one step further, let's divide it by -3. So this will be -5 is equal to a plus b, and I'll just hang on to that for a few minutes. Now let's use the yellow one again. 12 is equal to a minus b plus c. And this time let's subtract the purple one from that. So minus 5 equals minus 36a minus 6b minus c. Adding those together, which would this one be? Red. 12 minus 5 is 7. A minus 36a is minus 35a. And negative b minus 6b minus 7b. Again, this is another equation that I'm going to end up working with, and everything in here is a multiple of 7, so I would like to divide by 7. So 1 is equal to negative 5a minus b. And now I have my two equations with two variables, and you can see this actually worked out really nicely the way I did it, because all I have to do now is add these two equations together, and b is eliminated because b already has opposite coefficients in these two. I have plus b and minus b. So when I add these together, negative 5 plus 1 will be negative 4, and a minus 5a is negative 4a, which will tell me that a is equal to 1. I just divide both sides by negative 4. So that was a lot of work to find the value of one variable, but at this point we're actually almost done. The next step is let's take the fact that a is equal to 1 and put that back into one of our equations. Let's do this green one. That was negative 5 is equal to a, which I know at this point is 1, plus b, and just subtracting 1 from both sides, that gives me that b to negative 6. Now I know two of them. If I take the values of both of these two and go back to one of my original three equations that I constructed at the beginning, and let's do the yellow one. I like the yellow one. 12 is equal to a is 1, b is negative 6. If I'm subtracting negative 6, that's plus 6, plus c. That means 12 is equal to 7 plus c, and finally c is equal to 5. So going back to the form of a quadratic function, y equals, the a is 1, so 1 times x squared, that's just x squared, plus bx, that's minus 6x, and then plus c, that'll be plus 5. And there's my answer. It's y equals x squared minus 6x plus 5. It's a quadratic function that contains the points negative 1, 12, to negative 3, and 6, 5. To get used to this process, I recommend that you try it for another set of 3 points of your choosing, and just make sure that they're non-collinear and that no 2 points have the same x value. If you want to try see what happens if either of those conditions is not met, then maybe take these same 3 points that I gave you, and instead of doing 2, negative 3 here, maybe make that 6, negative 3, and see what happens. And if you want to see one where there are 3 collinear points, then try get rid of negative 1, 12 and put 2, negative 3, 6, 5, and if you add in 4, 1 as your third point, that's actually the midpoint of these 2 points, which is on the same line as they are. So give that a shot and see what happens, and good luck.